Well, contractility refers to how hard the ventricle is squeezing. An increase in contractility is going to result in an increase in stroke volume. Normally, the ventricles eject about 70 mils of blood out. With an end diastolic volume, let's say about 120 to 130 mils, that's going to be around 60%. So basically what you do to get that 60%, you just take the 70 and divide by 110, divide by 130, and that's going to give you a number which you multiply by 100 to give you a percent. So it's around 60%. More blood is pumped per beat as the end diastolic volume increases. When you look at end diastolic volume, if I increase it, we know by the Frank starting law of the heart's going to beat harder to move that blood out. But even if your heart's beating stronger with more blood going in, it still only ejects out around 60%. So the more blood that goes in, the more blood that goes out, but it's proportional. And so we see that you have a ejection fraction that remains relatively constant, around 60%. I'm going to give you ejection fraction questions. And you can use a calculator on this on the exam or on the quiz. So you need to memorize, though, to do an ejection fraction, I take my stroke volume, which is the amount of blood pumped out, and I divide that by how much blood was in that ventricle originally, which is your end diastolic volume. Contractility strength is related to Frank's starting law of the heart and fiber stretch, which we just went over. With extrinsic control mechanisms, here we have nerve innervation, hormones, and drugs that can affect contractility of the heart, and we'll discuss those in a little bit. When you look at the clinical considerations with heart failure, a failing heart gradually enlarges and eventually fails because it's not able to pump all the blood returned to it. Further stretching the cardiac muscle fibers in a failing heart does not increase the stroke volume after a while. You need to know what the symptoms would be for right heart failure and left heart failure. Generally, you'll have one initially, and then the other side will start to fail as well. When we're looking at just right heart failure, that's where you have failure of the right ventricle, which causes blood to back up in the veins that return blood from systemic circulation to the heart. Filling the veins with blood causes edema. If it's not able to move that blood out through the heart because the right side's failing, you're going to have increased blood pressure in the venous system, which is going to cause an increase in edema. You'll see this especially in the legs and the feet. And edema is accumulation of fluid in the tissues, or that interstitial space. In left heart failure, this is where you have the failure of the left ventricle that causes blood to back up in the veins, the pulmonary veins. They're going to return blood from the lungs to the heart. Well, if that blood's not able to move through that into that left ventricle and be pumped out by the left ventricle, that blood's going to accumulate more. You'll have more pressure in the pulmonary veins, and this is going to cause edema in the lungs, which makes breathing really difficult. That's where you're going to have congestive heart failure. Here's a heart of somebody who was severely hypertensive. This is the left ventricle. This is the right ventricle. And you can look at the muscle mass of that left ventricle, how it tried to adapt to increasing total peripheral resistance pressure or high blood pressure to be able to overcome moving that blood out of the heart against higher pressure. In the next video, we're going to be going over extrinsic regulation of the heart. And we're going to focus on the nervous system and the endocrine system's ability to regulate the heart.